Welcome back to the 9th edition of ITECAM conference. I'm Alex Bolbaco and I will have the next session for today. It's called Fitness and Workout for Software Architecture. What I'd like to talk to you about in the next 45 minutes roughly is about some of the techniques and some things that have came up in the recent years in architecture, and I think that they are very interesting for anybody who has challenges with software architecture. These are specific problems that tools and techniques and practices are solving, and these are all techniques and practices that we have seen working very well with our customers. As I mentioned in the introduction, there are a number of architects who reached out to us and asked us to help them in various areas of their activity. And what we did was to introduce them to some of these techniques, experiment with them, and they work really well in practice. A few things about the slides. I'm using Mentimeter. There will be some moments where you can interact with the slides. You can go to, if you want to interact with the slides, visit www.menti.com and use the code that's displayed on the screen, 26806345, and you'll be able to join, to see a few, and to interact with the slides. A few words about me. I'm CTO and polyglot programmer at Mosaic Works. I have 20 years experience in multiple countries in Europe and in US. I'm author and trainer. I recently published my third book, which is Hands-on Functional Programming in C++. I'm fascinated by functional programming, and one of my first programming languages was C++, so this was very interesting to see how it works together. I've been involved in large projects in many industries, including energy, telecom, media, automotive, gaming, and e-health. These are some very interesting domains. And I like to contribute to technical communities. The software craft communities are particularly close to me because I align with the values and the learning that is happening there. And whenever I am able to travel, which I used to do a lot before the pandemic, I like to join events in the software craft communities around Europe. It's really great. And lately I'm focused on architecture, repeatable engineering, and methods for refactoring legacy code. I'm also focused on solving problems and improving designs. I've come from, in the beginning I used to like technology and play with it. Now I like to solve problems using technology, and this has given me a different focus. Okay, so what, just quickly so that I can also see the chat. Okay, cool. Just know that we are on a 20 seconds delay. This is how Crowdcast works, so some of the, especially interacting with slides, will be a bit delayed. All right, so I want to talk to you about a few, as I said, a few practices, a few techniques that we've been using for ourselves, and we've been helping customers use. Architecture diagrams as code, one trend. Fitness functions for architecture, architecture decision records, and finally the workout part. Well, the first three are more about the fitness of the architecture, but the workout part is architectural katas, actually practicing how to do architecture. And let me start with the first, the architecture diagrams as code. The goal here is to communicate architecture with simple tools. And the reason for this whole domain to spark up is that on one hand we need architecture diagrams. They are extremely useful because we can They help us remember, they help us communicate, they help us evolve architecture, and they help us collaborate with everybody. One of the biggest challenges of new software architects is realizing that you need to communicate with a lot of people who are not necessarily technical. You also collaborate with programmers, of course, but there is a lot more than that. You need to discuss with infrastructure, with QA. These are also technical, but you need to discuss with product managers, with many other, with business people. And then it helps much more to have some kind of diagram to discuss these things on rather than huge documents. However, in the recent years, some things have happened due to the agile software development paradigm. Many companies, many teams, many people have understood that we don't need documents anymore. Let's draw everything by hand, take a picture, which can really work. It's quite fun to do that. And actually, if there's one piece of advice that you take from this talk, use a whiteboard to collaborate. Whiteboards, I have seen whiteboards again and again having a very positive effect on creating architectures fast. However, a whiteboard is not enough because it's not standard, and perhaps other teams won't understand what you're writing there. It's different when you are drawing and discussing. That works really well. But it doesn't help if you leave that diagram, hand-drawn diagram, for like 2 years, and then somebody who hasn't been in the conversation tries to talk to you about it or tries to read the diagram. There's much more to these diagrams than just the drawing. And so the question is, can you draw? This is the second question, because often, and I admit that, I can make some drawings, but I'm far from creating some nice diagrams. I would need a lot more practice drawing to do that. And so I have a question for you. I'm curious, how do you create architecture diagrams? And there are a few possible answers here. I don't do any diagrams. I use a general diagramming tool like Visio or Dia or whatever, some of those tools that can be used like for any type of diagram. Some people use slides, some people use whiteboard paper, post-its. Some people use specialized tools like Visual Studio or Enterprise Architect, or if you have some of those huge UML tools that you can use. Through code, and this is the part where we'll discuss a bit, PlantUML, Structurizer, GraphViz. These are a few tools that you can use to create diagrams through code. Or other, and I already see somebody posting in the chat, draw.io. Yeah, that's a good one, and I think it's yeah, I would think is this more of a general diagramming tool? If I remember correctly, it's more like a drawing tool, so it's not specific to UML or to architecture. Pavel writes, Mixup.io, Miro.com, sequencediagram.org. Interesting. So there are all kinds of mixes here. It's quite cool to see. Alex in the chat says draw.io plus whiteboard. All right, so it seems that draw.io has quite a following, in at least in our group here, and Miro. Cool. Okay, so I will switch in a few moments from this slide. Miro, Michelle says Miro, Lucy Chart, Javier, and Stefan, or Stefan. Cool, that's quite interesting. Star UML, okay. So Lucy Chart, I haven't seen Lucy Chart. It might be interesting to see. Why add graph editor? Okay, I think we have a hardcore drawer here glyphy. All right, so that's interesting. Let's see. I will just go through a bit of history. We started using diagrams around 1980s. Around the 90s, some people got together, and because there were different languages for diagrams, different notations that were very widely different. Grady Butch and a few other people, Rebecca Worsbrook, they got together and started to unify this in what is now known as UML. Then we have Agile working software over comprehensive documentation, and we understand from this that we don't do diagrams anymore, or not so much. And today, what I see usually is less UML, more hand drawings. And I have to say there is a reason for this, because UML is useful, but it is extremely complex. You got to 700 pages and 14 diagram types. Most systems don't need all of that. And we often don't learn the whole UML thing. So since we like code, right, we're tech people, we like code, I like code, how about creating architecture diagrams as code? And a few options have appeared in the recent years. We have PlantUML, Structurizr.dsl. I will look into these two with a few examples. GrevViz diagrams, ASCII doctor diagram, web sequence diagrams. These are all tools that you can use to create diagrams from code. PlantUML is an interesting tool. It's Java based, but it doesn't really matter. You can run it anywhere. It has a specific language that you can use to define diagrams. And I think that's the interesting part. And then you can parse that language through PlantUML, and you will end up with diagrams. And the second one, I see Marco mentioning the C4 model by Simon Brown. Simon Brown has also created a modeling tool for the C4 model called Structurizr.dsl. If you don't know the C4 model, it's a really good, not necessarily replacement for UML, but more like a way of thinking about architecture that's easier to get, easier to grasp, especially for new architects. And this tool, Structurizr.dsl, it helps you create the diagrams and the models that you want. So let me quickly show you how these things look like. Just a moment. I will just to quickly show you how PlantUML looks like. By the way, these are, if you go to github.com/mosaicworks, you'll find the Git repositories with all these examples, and you can play with them and try them out. So let's say, for example, you have to write like a deployment diagram. This is how PlantUML looks like. You have a frame with internal system. This is just separating blocks inside your diagram. And then you have keywords like actor, cloud, node. Inside the cloud you have node. Inside the node you have components. And I won't go into a lot of details because we don't have much time. But what you define then is interactions between these systems. So, and you say buyer can go to ticket shop can go to tickets database, and so on. And the end result is, let's see, no, we should be in out. So if we have, let's say, the deployment diagram, you pass it through PlantUML and you end up with this diagram. Now for this diagram, I've also made a few adjustments. I use some custom themes that are also open source, but to make the diagram nicer. And There are multiple types of diagrams, but I won't go into all of those. Let me just quickly show you, well, it can also generate SVG, which is great, because if you want to print a poster, SVG is great. I mean, if you really work in the same office, which I hope will soon happen again, it's sometimes useful to have a big diagram posted in the wall, and SVG format is great for that. So, and let me quickly show you the makefile for this. I have a simple makefile that allows you to generate this. So it's just about running plenty.ml and including a style and then telling it to output this somewhere. Okay, I don't have a lot of time to go through this, but if you're interested, you can play with GitHub repository that is available. I will post the links here, and you'll have them at the end after the conference when we post the whole videos. And then the next interesting thing is, as I said, structurized DSL. Here you have a DSL that allows you to define a model. Plenty.ml is more focused on a diagram, but in this case we are more focused on a model. And the difference is that in a model you have, for example, we can define a person that is a buyer, a person that is a passenger, and then we can reuse these entities that we create later on. And by reusing these entities, we then have different views of those. And the different views are the C4 views: system context, system landscape, container. And you can also do some styling, but that's less, let's say, interesting. And what we get out is the structurizer, let's say the container diagram, quickly show you. But the nice thing about defining a model is that from that model you can generate a number of different views, and each view represents basically a diagram for your system. And you don't have to repeat. In Plenty.ml you have to repeat the same entities again and again. All right, so this is just a quick introduction, and what I invite you is just to play around with the GitHub repository. Is very easy to use. It's just, you can just call a makefile and it will work. Okay, so quick conclusion to this: we can use code to create architecture diagrams. Why is this interesting? Well, I think it's interesting because we can store this in source control, and we can actually version them. This is different from versioning images, from versioning diagrams. You can actually version and see the changes in your source control when your model changes. And it's nice that you can add reference to relevant documents. You can have this part of continuous integration and build the diagrams, have them available on a server somewhere. There are also integrations with other tools. So for example, when you define these models, you can use tools that analyze the models and tell you if you need to change anything. But I admit they are not particularly familiar to most people. You have indirect control of these diagrams by changing code or changing the DSL or markup, rather than going and doing a drawing in a specialized tool. Personally, I love this approach because I'm also very used. I wrote my first books using Pandoc and Markdown. I'm very used with the make for for a book or for an image. It's very good, and I also like that they generate SVG. So this is a very quick introduction to diagrams as code. Second idea, and these are ideas to try, right? It's not necessary to use all of them, but it might be interesting to use some of them. Second idea, fitness functions and architectural tests, and the reason for this is to keep the evolution of your architecture under control. How do you do that, and what do I mean by that? I will skip this. The thing is, software architecture is a lot about stewardship, which means the careful and responsible management of something entrusted to your care. If you are an architect, you don't necessarily own the architecture, but you need to be very careful on how you let the architecture grow, evolve, where does it go, and how well does it evolve in time. This is one of the challenges of software architecture. It's not only about today, it's also about tomorrow, it's also about 3 months from now, it's also about 6 months from now. And as an architect, I care about a few things: functionality, operational parameters, development speed, but also the future. I care about development speed in the present and in the future. I care about operational parameters in the present and in the future, not only about the present. And you already heard Ken talking about systems. Architecture is the result of a system. It's not the architect who comes and drops some diagrams and knowledge onto you and then everything goes fine from that. No, it's a continuous interaction between different elements in the system, between programmers and the architecture, between testers and the architecture, between ops and the architectures. And then you have customers, you have managers, you have technology changes, and you have partners that help you with various parts of your system. All these come together in a mosaic, and this mosaic leads to patterns of evolution in our architecture. And so we need to take into account complex system effects when we talk about evolving architecture. There are things that will emerge, there's order, there's feedback loops, there will be non-linearity in your systems. And your architecture will evolve, but as stewards, we need to ensure that this evolution preserves the desired qualities that we are looking for. It cannot just evolve in any direction. It can. So an idea here is to use, this is a metaphor taken from the natural evolution of species, using fitness functions. Define some functions, define some constraints that you set on an architecture to preserve desired characteristics. And this is an old idea, but how do we do that in a way that is also useful? It's easy to do, it's easy to maintain. Because normally the way you do that is by watching over the developers and making sure that they don't do anything that you don't want them to do as an architect. And that's not the nicest way of doing it, right? Another way is to coach them to understand the various characteristics and the needs of the system, and so they can then make those decisions in the context of these constraints. But then we all make mistakes, right? It's always the case that we have a bad day and we'll make a mistake in the code and we'll call something that we are not supposed to call just because we ran out of patience and it's, I don't know, it's late and we need to deliver. So in order to have these fitness functions, the next idea is to have automated fitness functions. Here are some examples of fitness functions. The UI layer should never call the data layer directly, in case you have a layered architecture. In case you have kind of an MVC style, perhaps the controller should never call the DEO object directly. Or all classes in the service namespace are annotated with a service, and so on. No class throws general exceptions, right? All kinds of rules that are not part of the coding rules, but they are part of the coding rules in a sense. The coding rules commonly include other things, and these are rarely or less often used, and in those cases it's possible that we will make some mistakes. So for each of those there is a reason. What happens if you have a layered architecture and you allow things to call each other however they want? You'll end up with spaghetti code between layers. Same as with microservices. If you have a bunch of microservices and they can all call each other, you end up with distributed spaghetti code. You want to have separation of constraints, you want to have low coupling, and so on. And perhaps you also want to have useful error reports. So let me show you just a quick example of what you can do currently with automated architecture tests. This is an application. Once again, you'll find it in our GitHub repositories. It's a different repository. The application doesn't actually matter. Let's just say it's a Java application that has an MVC style approach. So it has some DAO classes, it has some controllers. It's one monolith. It's not separated in multiple things. And what you have here is architectural tests written using a tool called Arch test. And in order to write Arch tests, you'll have you need to import, of course, the library, and you'll see all the technical details in the GitHub repository, and you can play with it. And then one such test looks like the following. You first get some classes together, you import some classes. You define an architectural rule using special Fluent interface, and then you can check those rules. And there are easier ways of doing that, but it's something you can try out for yourself. So you have here, for example, DAO class name should end in DAO, and we have a test that says, okay, these classes from combook DAO, so from that namespace, have name matching DAO, and it's a regular expression there. We have DAO classes should only have final fields, and this is, you'll notice, is disabled because it fails. I will show you the run results in a moment. Domain classes should only have getters and setters and toString, and then you have a bunch of method level tests or checks for the classes that you imported. Domain classes should be serializable. Domain classes should not call other classes. So if you have something, no classes should access classes that reside in package, service web DAO. DAO classes should not be called from the web, and once again you have the web namespace. No classes should access classes that reside in any package that contains DAO. And then you have a bunch of general rules, like should not access standard streams or should be properly annotated with things. It also has some specific code tools, checks. Let's run these tests and see what happens. A bunch of tests are passing. The interesting one is the one that is not passing, that has disabled but commented. And what it gives me is an assertion error, architecture violation. Classes should implement Java.io serializable was violated because this class does not implement the serializable. So this is what you get with Arch test. There are similar tools for .NET, and I think there are others in the making. But the interesting thing is the idea. How do you remember as an architect, as a developer, that there are things that you shouldn't do, particularly those things that you do less often, right? So just a quick conclusion for this topic. Architectural constraints are necessary. We can use automated tests to maintain these constraints. As a nice thing, you can actually integrate ArchTest with PlentyML diagrams as code. So the constraints that you define there turn into connections between the various parts of PlentyML components. But one thing that you need to take into account, don't over-constrain, don't under-constrain. There's always a trade-off you need to watch for there. All right. Third tool that I would advise you to try is architectural decision records. And the reason for architectural decision records is a very simple one. I work with some C++ teams, and often the initial architecture for the systems they are working on has been done like 10 or 15 years ago by some people who are no longer in the team, who had some good reasons for making decisions back then, but those reasons are lost in time. And you look at, as a new developer in the code, and you find it very weird. You have no idea why somebody decided to organize the system as it is organized. And we live with these decisions for years, and that's just the nature of the work. Some of these decisions are very difficult to change, because once you have a million lines of code and they are organized based on a specific structure, sure, you can invest in that and reorganizing them based on the structure that's more fit for how you are thinking about architecture today. But let's be honest, this will never happen in terms of investment because it's too high an investment. So then we need to remember actually what made us make those decisions. And a solution to this is something called an architecture decision record, which is a document, a very short, simple document that describes a few things. The problem that you need to solve, the context in which you are making this decision, the decision that you made, alternatives that you took into account, and trade-offs for each alternative. There are multiple ways of writing an architecture decision record. These are the things that I believe are important, and I would include them in any ADR. But there are other templates. There's a simple template by Michael Nygaard who talks about status, context, decision, consequences. So it doesn't talk about, for example, alternatives and trade-offs of the alternatives. There's another template from Shubmat, github.io, that talks a bit about the alternatives, but just has the chosen alternative without going into details for each of the alternatives. And then there's something called the why statement that serves as a brief of the ADR. In the context of use case or user story facing concern, we decided for option to achieve quality accepting downside. This is a nice single sentence that you can use to start your document, but I believe it needs more. So let me quickly show an example. This is an example that I wrote actually using a tool called ADR Tools. And ADR Tools is a tool that allows you to generate these documents in your source control. And let me show you, this is just the first one. This is the one that it generates for me. It says we need to record the architectural decision made on this project. We'll use architectural decision records and see the article. So this is kind of the default one that that it generates for you, because indeed it is a decision to start using architectural decision records. And then I wrote another one which is related to actually one of my decisions in terms of architecture, that says use LaTeX for document generation, and it has a context. We have some documents that are created by copy pasting right now, and sometimes we make mistakes doing that. We have decided to use LaTeX. This is the decision. Consequences, both good and bad consequences. The good one is LaTeX is very capable. Downside, syntax is unusual. We have looked at a number of alternatives, and then for each alternative there are some information about, what are some strong points and why in the end we decided not to use it. And so this is how, for me, an ADR should look like. And you have a date here that's useful and the status. And these documents you can easily create in your source control or use some specialized tool, but I prefer source control. So I advise you to use them, store them in a source control or a wiki or a documentation site, write new ones, keep them short and to the point, but don't turn them into bureaucracy, don't turn them into approval processes. And finally, we have all these nice, interesting techniques, plus many, many more challenges as architects. How can we get better? And the way to get better is by using deliberate practice. Deliberate practice is a style of practice where you solve problems again and again, and you have very fast feedback on the resolution of problems. The challenge with software architects is that we only build a few architectures in a career. We don't build a lot of them. And so we need to make this cycle faster. And how do you do that? You pick an architecture problem, you take 45 to 90 minutes to draw the diagrams and decisions and whatever. You can pick some of the tools that we talked about, so you can also use code for generating the diagrams, or structurizer, or use the C4 approach, or use some ADRs to document why you made certain decisions. Present the architecture, review, repeat, and get feedback. And this is done in short groups because you can get feedback from one another. It is also best if you do it with people who have experience in architecture and who can give feedback. You can find some exercises here. They are created by Ted Neward, archkatas.herocoop.com, or searching for architectural katas, and it's easy to start. Organize some of them, invite some facilitators if you don't know any. We have a lot of experience with facilitating this, but take over after you learn the drill, because it's quite easy to do. We have a few interesting learning programs for architects. You can check the calendar, you can ask us for various learning programs, and From Developer to Architect one helps you become an architect, or helps you solidify your knowledge as an architect. All right, this was my talk, and I'm not sure we have a lot of time for questions, but I'll try to answer them. Who writes these Arch unit tests? They look like the responsibility of the architect, but can you write them beforehand when there's no code to test? That's an interesting question. I prefer an approach where developers are involved in the architecture as much as possible. This means that you need to have conversations with developers, bring in the problem, bring in the new constraint, talk about it, and discuss it with the developers. And then I would recommend that the architect with the developers pair program and write these tests together, because first, it's nicer. Second, the developers will understand the reasoning behind it. It's not enough to have rules. It's better if you understand the reasoning behind the rules. Can you write them beforehand when there's no code to test? I mean, if you are starting green, completely green field, what I expect to happen is that you'll create some sort of skeleton for your application, and then you can write some of these rules, and then these rules evolve in time. So that's how I see it. Second question, is there a way to combine ADRs to structurize or plenty OML? It would be great to have ADR and the actual diagrams in the same place. I mean, you can have them in your source control, right? And that would be an easy one. I'm not sure if I can add anything more here. I would keep them in source control. I would keep the diagrams as code, and you can keep perhaps multiple versions if you want in the source control to see an evolution, but anyway you have versioning in source control. So yeah, that's what I would do. And yeah, don't forget that you can reference from ADRs. You saw that some markdown format, so you can from an ADR reference a diagram, and from a diagram reference the ADR. So that's another way to do that. All right, I think we are out of time. I'd like to thank you for your questions and for your involvement in this section. I see people are saying nice tools. Cool. I love it. It's been great. We'll take a few minutes break and come back with the next session.